Alright, today class we have your example project blueprint. If you look around, we see that there are a couple different views. We have our dimensions, we have our weld symbols, and we have our title block down in the bottom corner. We also have on another page, I'm going to show you your bill of materials. Those are the 5 things that we're going to be looking for your grading rubric for this project. So this is an example I chose to do. I've already created the project. At the end of this video, I will show you the final product. Now, to start us off, let's just go ahead and look at our title block that we have down here. So if I can zoom in for you, we see that this is where we find both the name of what the product is called. I'd have a company name I made up, a cool little name based on my name. I want you guys to come up with cool little names for your companies that you put on here. These are just an example of how we give out a bunch of information to the fabricator from the engineer. We see we have a quantity number, we have an order number. Over there on the top right, we see what our material is made out of. For this drawing, I have chose to draw this in a 1/4 inch equals 1 inch scale. I don't have any specific notes specified in my title block. This is drawn by me. Those are my initials. You'll always see either the drawer's initials, and sometimes you might even have an inspector check a drawing like this, followed by a date. We also see our tolerances here. I put plus or minus an 1/8 inch or 1/2 degree on dimensions and angles. This is pretty standard for a lot of stuff. And then we see also the revision record. This was drawn today, April 9th, 2020, here in our quarantine world. Now, if we look back in chapter 3, under notes and specifications, we have a couple of different ways that we can see these title blocks. These are often the typical drawing masters that you'll get from an engineer. We'll show some kind of ruled title block. There's different ways to do this. As you can see, you can have our tolerances off on the side in different ways. That might list you a certain amount of decimals along the way. Or you could even just have, like I've done, which is the drawing block in the top here, a very simplified version of this, okay? And just to show you guys, this isn't just what you'd see in a textbook. I have a drawing for you I'd like to show you that specifically shows that there are multiple ways to do this. Now, I've crossed out some names because I don't no longer work for this company. But, we can see that we can give a lot of the information. We can see different engineers who've drawn this. We have like a revision record over here where we've had different revisions added along the way. And then also, some people will come put the tolerance in a special little box. So for all of our dimensions, we have plus or minus an 1/8 of an inch. Any angles, plus or minus 1/2 degree, and so on and so forth. So this isn't just what we teach out of the textbook and hope that you'll run into it. This is literally what you're going to run into in the real world. So if we can take this away and get back to our drawing, I'd like to specifically point out a few things about the orientation of our views, right? So I told you that you are going to be required on your criteria to give me at least 2 views to describe to me what your project is. Now, because this is a very simple project, I chose to give you a few more. So if you see, if we start off right in the middle over here, we just have our front view of my wall-mounted plant hanger here. And if you see, they have to be oriented to each other correctly. So right above the front view, we have our top view, right? So this gives us a viewpoint of what we'd be looking at from above the product. We'll also see over on the right side, because it's to the right side, we can see what it looks like to look at this product from the right side when it is complete. Notice by doing this, I'm able to leave dimensions that measure in both views. So between our front view in our top view, I have our overall width of the product. This is 8 inches if you can't see that. I know this is hand drawn here. But we also can do it with our front view and our right side view. So we know that this bottom section down here where the plant is actually going to sit down is going to be 8 inches as well. And the overall dimension I've put is going to be 16 inches. And then you see I have how far it's going to stick out. I've got 6 and 15/16 to the inside. That's just for the sheet metal that you're going to see here. And then I have 7.5 for the round rod that I use to line the edging on the top. So I have different dimensions that describe different parts of this drawing. Now, we also can do a viewpoint. If you look down on here in the bottom right, you see I said C detail A. If you come up here in the top right, what I've done is you sometimes see this in blueprint drawings, and even so much as the one that I showed you a second ago, which is a pipe support. They even had their own detail cut out. I think if I look at this, it says this is a burn template. This is something you can give to a company that can pre-cut metal for you. But because I did this by hand, I had to actually get this math. But I could order this metal correctly cut to these dimensions. So my side pieces here, I have the top part there is going to be 8 inches. The kind of hypotenuse there is 10 and 9/16, and then the downward piece is 8 and 15/16. Now, just by a simple drawing tool, I'm able to actually get this pretty much to scale. Now, I happen to already know the angles for this. We have 77.5, 55, and 47.5. These all add up to give me the angle that I'm looking for to make these, because in reality, the drawing that I'm looking at is a little more complex because I'm getting angles in 3 dimensions. So I needed to take the time to actually get those. That way, if I wanted to recreate this over and over and over, I can always do that, and it comes out to very approximately close to what I want to see. So we have our front view down here and our top view that also has a very important part of your project blueprint, which is our weld symbol. Okay, so down here in the bottom, you see I have an arrow drawn with, on the arrow side, we have an edge weld call out. And I even put a specific note saying that I did this with GMAW. So I did all of my welding here with a little MIG welder up at campus yesterday. We also note, if I look in my top view, I gave a weld call out for both the arrow side and the other side. See, on this side we have it on the arrow side. We have an edge weld because I have flat edges between that round bar and the edge of that sheet metal. You may even call this a J groove, but we'll go with an edge for this example. But I also have on the other side of a fillet weld. So where that actually is translating to is if I come down here in the front view, up underneath that round bar, I went and put a fillet weld all the way underneath that, okay? So if there's no call outs on your weld for distances or lengths of the weld, then you must assume that it is to be welded all the way across. Now you might see specifications over here in the title block or maybe above the title block that give you a call out for weld specifications. But I didn't do that for this example. I didn't want to give you all too much, okay? So with this being said, we have our drawings with our dimensions, our weld call outs. All that is going to leave us with now is our bill of material. Now, bill of material can be something as simple like we have here. I only have 2 different kinds of parts. I have one piece of round rod I went and bought. I got a little 1/4 inch round rod that's 48 inches long, and I cut it up into the pieces I need. Also, my second part, I got 3 pieces of 12 inch by 12 inch by 12 gauge sheet metal. This is the metal that you guys would receive at campus for you guys to do your projects coming up. With that being said, bill of materials can actually hold quite a lot of information for you. So if I pull back a bill of material from the description of the thing I see. You can even include sometimes, other things that welders aren't necessarily related to. Like this example includes both the paint and everything. The reason why we have all this information is so that when we are, if you go into individual work, working for yourself, maybe you need to calculate the price it's going to cost you to build this project before you actually go out and make it, so that you can give your customer a quote. Now, a lot of you guys are going to work for places where all this work is done for you, and you just receive a blueprint that looks something like this, and you're told to weld it, and that's great. But I think it's very interesting for us to know, as individuals, to know how to put all this together for ourselves. Now, a lot of this can be done if you know someone who has AutoCAD, who can draw this up. A lot of times with certain drawing softwares, you can find them that will put like the scale for you. He'll automatically do the angles, the links for you. You can get a lot of this done for you on a computer. However, we would like to be able to do it ourselves.